Hello, my name is Jacob Halverson, and this is my Project 3 demo. So for my Project 3, I built a Cipher machine that can encrypt and decrypt messages. And how this works is on A0 through A4, the user will enter a number, 1 through 26, that will correspond to a letter in the alphabet. On A5 and A6 represents a key value that will affect what the ciphertext is. And then A7 is a flag where if it's not set, the machine will be in cipher mode. So anything you enter on A0 to A4 will be encrypted and output on B. And then if you enable this flag, it'll be in decrypt mode. So anything you enter on A0 through A4 will be entered as the ciphertext and will be decrypted into the corresponding plain text. So for an example, we'll run this with the key set on both values A6 and A5, and then we will encrypt the message divert, which corresponds to these numbers up here for D at 4, I at 9, and so on. So right now we have the key set. This is in encryption mode. Now we'll run this, and I have in the terminal down here, it's outputting the ciphertext of whatever character is inputted here. So the first character will be D, who would enter 4 right here. And we can see that our ciphertext is now N, which corresponds to 14. So we can see right here. Then the next letter would be I, so we would enter 9 on A. So that's going to be A3, A0. And then B will output 19, which corresponds to S. And if we continue on like this, we will end up with this ciphertext. This ciphertext for divert. Now, if we go ahead and change the flag A7, raise that, now this will be in decipher mode. So we would enter in our ciphertext. So first we would enter 14. And that would give us B is equal to 4, like this. And then we would enter 19. And that gives us B equal to 9. And if we keep entering in the rest of these ciphertext values, it'll give us the original plaintext. Now, as an example, if we use the wrong key, so let's say we set it to 1, 0 on A6 and A5, this will end up producing these values right here. So let's enter 14. And that'll output B is equal to 7. So see right here, it's outputting G. And if we continued entering the rest of the ciphertext values, we would get GLY, HUW, which is just nonsense to anyone reading that. And they wouldn't be able to tell what the actual hidden message would be. Now, I'll show you this again with a different key. So if we did 0, 1, and we entered in the same plain text, so we did 4, that would give us 26, or J, excuse me, it would actually give us 8 for H. I had the decryption mode on. And if we entered 9 again, here we go, 9, we're going to get B is equal to 12. That correspond, or 13. That's going to correspond to N. So we get HMZIVX, which is a different ciphertext than what we had before. So this key affects what our ciphertext is going to be. And then if we put this back into decryption mode and enter these ciphertext values back in, it would give us the original plain text again, as long as we have the correct setting. And that is it for my demo. Thank you.